In today's lesson, we talk about power. Look, I even drew a picture of myself flexing. Oh, I forgot the hair. All right. So, what is power? Well, that's what I want to tell you about today. Specifically, we're talking about the power of a test, like a significance test. And what I want us to be able to do today is to be able to interpret power and also describe what factors affect the power of a test. So think of power as a good thing, like people want power, people want to feel powerful. So, in the same way, we want our tests to have as much power as possible. So let's do a quick review of I call these the truth tables for significance tests that tell us the errors. So this is a little bit of review from yesterday. Oops. Let's make this pen a little smaller. So your decisions are over here. You only have two decisions in a hypothesis test. You can either reject the null or fail to reject the null. So let's see what happens if the null is true and you reject it. You're making the wrong decision here. You're making a type 1 error. So that's the ho is true, make the wrong decision. So if the ha is true and you make the wrong decision, that's the type 2 error. Okay, well, what are the other boxes? Well, if the ho is true and you fail to reject it, so that means you didn't reject it. That's a good thing. Same thing over here. Ha is true, so you reject the ho. All right. So let's talk about what power means. I'm going to outline this in red because red is a powerful color. So power is the probability that you reject the ho when the ha is true. So last year my students said, why do you have to be so confusing, Miss Dang? Like, these words just don't make sense. How they like to say it last year is if you reject the null or the ho, and that's what we all love doing. We love rejecting that null. So you're rejecting the null and you made the right decision is another way of saying what I wrote down here below in red. Reject the ho, the ha is true. We reject the ho because we made the right decision. So you can think of it that way. We rejected the null because we love rejecting the null and we were right. So how do I interpret power? And power is usually given to us as a percentage between 1 and 100%. So I'm going to write it right here. If the ha is true, and I'm going to write this in black. Black is what I want you to insert at specific value, include the context. There is a power. I'm going to change this. Black means you have to substitute something for it. There is a blank chance of finding convincing evidence to reject the ho. And then give me the context right there of the ho. Okay. That was this right here, the learning target. Okay, that's how we interpret. And then now let's talk about what factors can affect the power of a test. Remember, we love power, we want more power. So how to increase power. Step 1, work out more. Just kidding. Step 1, increase your sample size. I say this all the time. It's always better to have a bigger sample size. Your variability is going to decrease. You're going to get closer to the truth. Or you can increase your alpha level. Better yet, do both of these. Why not? But yeah, I'm getting ahead of myself. Increase the alpha level. So usually the alpha level's at 5%, so anything below a 5%, I reject the null. But what if I increased it to 10%? I'm going to reject more values that I find, more p-values now. Or what if I increased it? This is ridiculous, but 50%. I'd be rejecting nulls all over the place. More on this later. Okay, last thing that you can do to increase the power is to increase your distance from the ha. So what does that mean? It depends. I'm going to get into this more later, but for instance, if your ha was p is less than 100, you want to get as far away from 100 as possible. And since this is less than, then I want to pick a really low value, like 3. This is ridiculous, but 3 is super low. So if I had, let's do another example. So what if I had two values? I had 50 and I had 60. Which one would increase the power more? Well, this one, 50, because it's further away from 100. So what happens now if you had this? P is greater than 100. You want to get further away. So I would rather have 150 than 101. 150 is much further away than 100. So just increase the distance, check your inequality signs there. All right, that's it. Great. I'll do the example problem now. And yeah, okay. So flashback, think back to a time before quarantine and whatnot. So remember when we played basketball and I told you guys that I was an 80% free throw shooter? Well, so Eddie doesn't believe me. He thinks I'm a less than 80% free throw shooter. But, he doesn't want to say anything because, nobody wants to make Miss Dang upset. Just kidding. Miss Dang, so I have a lot of I spelled this wrong. I have a lot of free time during quarantine right now, so I decided to take another simple random sample of 50 throws to prove myself to you guys once and for all. So here's our original hypothesis, and let's write these in words. So the hoe of p equals 0.80, that was me being, like, if the hoe is true, that means Dang is truthful, because I told you guys I'm an 80% shooter. If we find out I'm an 80% shooter like this null, that means I was telling the truth. This one means that I'm exaggerating a little bit. Maybe I'm not that good. I'm actually less than 80%. But if we find that the ha is true, that means, I was exaggerating. And then recall that p was the true proportion of my made free throws. Okay. All right. So unfortunately, I took away a lot of the fun and I calculated the power of the test for you, which is actually quite common. You'll see it on the AP exam, like they already give you the power. If they do, then just interpret it. That's number one. So if Dang is actually a 66% shooter, the power of the test to determine if I'm exaggerating using alpha equals 5% and sample size of 50 is 0.76. Interpret the value of the power. Okay, let's do this. I'm gonna copy this. Okay, so I want to show you what I'm going to change in this context. So if the ha is true, okay, so I'm looking at the ha at specific value context. So the value is what they usually give you. I want you to get that from the problem. So this question is claiming that the specific value is 66%, and the context would be that I'm a 66% free throw shooter. So I'm just going to plug that in. So if the ha is true, and this Dang, because the ha is just like a number, it needs to be below 80%, and then they give you this number, 66, random number, but it is below 80%. This Dang is 66% free throw shooter. There is a, okay, well, the power I highlighted in yellow was 0.76, so I'll just put that in here. 0.76 chance of finding convincing evidence to reject the null. And I need the context of the null. Well, the null is that I'm truthful. I'm an 80% free throw shooter. I don't care. I don't really mind how you put it here. If you say I am an 80% free throw shooter or I'm untruthful, I'll just say that she is an 80% shooter. That's simple. Okay, step 2. Number 2, describe a type 1 error in context. What is the probability of making this error? I usually just write the notes to myself. So type 1 means the hoe is true, wrong decision. So writing this alone will give you no credit here because you need the context, but I usually just write this to remind myself of what I have to do. Okay, so if the hoe is true, then that means dang, I'm taking this context right here. Dang is truthful. I am 80%. Dang is truthful. But we make the wrong decision, so we think she lying. Okay? What is the probability of making this error? I'm going to jump back to this. Let's do type 2 error first. So type 2 error, that's the ha is true. Wrong decision. Okay, so the ha is I'm less than 80%, I'm lying, so dang is lying. But we make the wrong decision, so we think she's truthful. So basically, I'm talking big game, I'm pretending to be 80%. I'm actually not, but you think I am being truthful. That sucks. Okay, so let's do the probability now. If you remember the video from yesterday, what do you have to do before asking out your crush? You do a significance test because you're only going to be wrong 5% of the time. That's type 1 error. The probability of type 1 is always going to be equal to your alpha level, and in this case, alpha level is, we set it up here, 5%. Okay? Type 2, what is the probability of making this error? Last year, some of my students would say, oh, it's 95%, because 1 minus this is 95%. No. But I'll tell you what it is now. So probability of type 2 is actually 1 minus the power of your test. So what was our power? It was 0.76. Okay, so I'll just do 1 minus 0.76, and I get 0.24. Okay, so there, and there. So your chances of making a type 1 error are 5%, and your chance of making a type 2 error is 24%. So, you're a little bit more likely to make a type 2 error, but whatever. All right, number 4, we always want to increase the power of our test. Remember, we love power. How can we adjust the following factors to increase power? Remember what I said earlier about sample size? You increase that sample size. Why? Because it's going to decrease your spread, your standard deviation. I just say variability encompasses all of those things. Or what I say in class, it gets us closer to the truth. It's always better to have a bigger sample size if you can. All right, what should we do to the alpha level to increase power? Well, you increase that alpha level. It makes rejecting the null easier. And then alternative P. What I mean by this is that just have a different value for your proportion. So what you want to do is you just increase the distance from the ha. So in this case, because our alternative hypothesis P is less than 0.80, I would want to go lower because of this thing. Go lower. Pick a value that's much lower than 0.80, like 0.40, or I don't know. Well, here, I'll write a few values. Which one would give you more power? This one, because 40 is much further away from 80% than 60 and 78. Okay, and then last thing, I left this outside, didn't think anything of it. When I came back, my husband had done this to me. Awkward. All right, I will see you guys later. There's a check for understanding. And then I'm going to have a few practice problems to review what we learned yesterday and today since these concepts are related. Heirs and power.